Autoscaling is a cloud computing feature that automatically adjusts the amount of computational resources based on the current demand. This ensures that applications have the necessary resources to maintain performance while optimizing costs. In the context of Azure, autoscaling can be applied to various services such as virtual machines, VMs, app services, and Kubernetes clusters. The primary goal is to handle varying workloads efficiently without manual intervention. Autoscaling is crucial for modern applications that experience fluctuating traffic. It helps in maintaining application performance during peak times and reduces costs during low traffic periods. For instance, an e-commerce site might experience high traffic during sales events and low traffic during regular days. Autoscaling ensures that the site remains responsive during high demand and cost-effective during low demand. This dynamic adjustment is essential for both user satisfaction and cost management. Azure offers two main types of autoscaling: vertical and horizontal. Vertical scaling involves adding more power, CPU, RAM, to an existing machine, while horizontal scaling involves adding more instances of a machine. Horizontal scaling is more common in cloud environments because it allows for better distribution of load and redundancy. Azure's autoscaling capabilities primarily focus on horizontal scaling, making it easier to manage and distribute workloads across multiple instances. Azure Virtual Machine Scale Sets, VMSS, allow you to create and manage a group of identical, load-balanced VMs. VMSS supports autoscaling, which can automatically increase or decrease the number of VM instances based on predefined rules. These rules can be based on metrics like CPU usage, memory usage, or custom metrics. VMSS ensures that your application can handle increased load by adding more VMs and reduces costs by scaling down during low demand. Azure App Services provide a fully managed platform for building, deploying, and scaling web apps. Autoscaling in app services can be configured based on various metrics, such as CPU usage, memory usage, and HTTP request count. You can set rules to scale out, add more instances, or scale in, reduce instances, based on these metrics. This ensures that your web applications remain responsive and cost-effective, adapting to the changing load automatically. Azure Kubernetes Service, AKS, supports autoscaling at both the node and pod levels. Cluster Autoscaler automatically adjusts the number of nodes in your AKS cluster based on the resource requirements. Horizontal Pod Autoscaler, HPA, scales the number of pods in a deployment based on CPU utilization or other select metrics. This dual-layer autoscaling ensures that your containerized applications can handle varying loads efficiently, maintaining performance and optimizing resource usage. Configuring autoscaling rules in Azure involves setting up conditions under which the system should scale in or out. These conditions are based on metrics like CPU usage, memory usage, or custom metrics. For example, you can set a rule to add more VM instances if CPU usage exceeds 70% for 5 minutes. Similarly, you can set a rule to remove instances if CPU usage drops below 30% for 10 minutes. These rules ensure that scaling actions are taken only when necessary, avoiding unnecessary costs. Monitoring is a critical aspect of autoscaling. Azure Monitor provides a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premises environments. You can set up alerts to notify you when scaling actions occur or when certain thresholds are met. This helps in understanding the behavior of your applications and the effectiveness of your autoscaling rules. Alerts can be configured to send notifications via email, SMS, or other channels, ensuring that you are always informed about the state of your applications. While autoscaling helps in optimizing costs by adjusting resources based on demand, it's essential to monitor and manage these costs actively. Azure Cost Management and Billing provide tools to track and analyze your spending. You can set budgets and alerts to ensure that your costs remain within acceptable limits. By combining autoscaling with effective cost management practices, you can achieve a balance between performance and cost efficiency, ensuring that your applications run smoothly without overspending. Implementing autoscaling effectively requires following best practices. Start by understanding your application's load patterns and setting appropriate scaling rules. Use metrics that accurately reflect your application's performance and resource usage. Test your autoscaling configurations in a staging environment before applying them to production. Regularly review and adjust your scaling rules based on the observed behavior and performance of your applications. By following these best practices, you can ensure that your auto-scaling strategy is effective and efficient. Consider an e-commerce platform that experiences high traffic during holiday sales and low traffic during regular days. By implementing autoscaling, the platform can automatically add more VM instances during peak times to handle the increased load. During off-peak times, the platform can scale down to reduce costs. This ensures that the platform remains responsive and cost-effective, providing a seamless shopping experience for customers while optimizing resource usage and costs. While autoscaling offers numerous benefits, it also comes with challenges. One common challenge is setting the right scaling thresholds. If thresholds are too low, you may experience frequent scaling actions, leading to instability. If they are too high, you may not scale in time to handle increased load. Another challenge is managing stateful applications that require data consistency. Solutions include using managed services that handle state, such as Azure SQL Database, and implementing robust monitoring and alerting to fine-tune scaling rules. The future of auto-scaling in Azure looks promising, with advancements in AI and machine learning. These technologies can provide more intelligent and predictive scaling, automatically adjusting resources based on historical data and trends. Azure is continuously evolving, and future updates may include more granular control over scaling actions, better integration with other Azure services, and enhanced monitoring capabilities. Staying updated with these advancements will help you leverage auto-scaling more effectively, ensuring that your applications remain performant and cost-efficient. Autoscaling is a powerful feature in Azure that helps in maintaining application performance and optimizing costs. By understanding the different types of autoscaling, configuring appropriate scaling rules, and following best practices, you can ensure that your applications handle varying workloads efficiently. While there are challenges, effective monitoring, alerting, and cost management can help you overcome them. As Azure continues to evolve, staying updated with the latest features and advancements will enable you to leverage autoscaling to its full potential, ensuring the success of your applications.